Hi, everybody, and thank you for joining us today for our webinar, Net and Blow Wall Insulation. My name is Kim Melton, and I'm going to be the moderator for today's presentation. Before we dive into introductions, I do want to go over a few logistics. First and foremost, like many of you, we are working from home. If we run into any technical difficulties today, we will record this webinar and send it out to your email directly rather than try to fight our way through technical difficulties. So we will let you know if that actually occurs. Also, if you have any questions or concerns throughout the webinar, you can submit them at any point during the presentation via the Q&A feature, and we're going to address these questions live at the end of the presentation. Now, a quick note before we get started. This webinar is for educational purposes only and shouldn't be used as a substitute for professional engineering design and/or documentation that's required by building codes, contracts, or applicable laws. You can definitely refer to our manufacturer-specific application guidelines and instructions and guarantee requirements on all projects, and those are available on our websites. And then for your materials specifically, since we are talking about specific machinery, please do refer to the owner's manual for your specific equipment or for all the operations discussed during the webinar today. Finally, we're going to follow the webinar with a survey, and this is your opportunity to provide us with feedback on how we did today. You can ask any additional questions you may have about the topic for the webinar, or even suggest topics for future webinars. And we use this survey as part of how we deliver the JM experience. And the JM experience is listed there in the bottom left corner of your screen, and that's people, passion, perform, and protect. And those are 4 key pillars of the JM culture. And we believe it's critical to make sure that we hear, understand, and respond to your needs in order to deliver the best interaction to you. And we offer webinars like this one to help educate the market and offer a tool and serve as a resource for you and your business. But that's really not a one-way street. Your feedback is a key component to helping us evolve to better meet your needs. So if you have any comments or suggestions as to how we can better accomplish this, or even if you feel like we've missed the mark today, we definitely encourage you to fill out that survey and use your feedback to improve our webinars and provide the information that has the most value to you in future webinars. We're also frequently asked whether or not we send out these presentations upon their conclusion. And we don't actually send out the presentation itself, but we will post a recording of it online. This is so you can watch it at your leisure, share it with your colleagues, but it also ensures that you have a presentation within its full context. So you're not missing any of the key details that we're going to talk about today. Now, we will send you an email when it's live on our site. So with that, I'm going to hand it over to Jacob Reeves to introduce himself.
Hi, everybody. I'd like to thank you all for coming today. My name is Jacob Reeves. I'm the Technical Services Representative for the Central Region of the United States. I've been with JM for about 5 years now, but I've been in the insulation industry for a little over 25 years. Today, we're going to discuss the basics of the net and blow system. Some of the things we're going to cover will be why we net and blow, the equipment setup, our fabric installation, and finally, how to perform a density check. So, net and blow system is an insulating system that uses Johns Manville's Climate Pro fiberglass insulation blown into place behind a mesh fabric at specific densities. Why would we choose this method over a more traditional install like fiberglass bats? Well, when done correctly, the net and blow system ensures a grade 1 insulation rating, while providing higher R values resulting from the higher densities. The net and blow system provides a uniform density, fills the costly air gaps that are associated with the more traditional way of insulating. Tests showed that a 4% void area from a poorly installed bat can cause 50% increase in heat loss. When done properly, the net and blow system eliminates these voids and does not settle. Because of its uniform density and seamless coverage, the system creates a blanket of insulation that custom fits to any size or shape cavity. This provides a uniform R value throughout the entire cavity, and because of the higher density, helps reduce some of the air infiltration. In this section, we're going to discuss some of the basic equipment needed and a few of the calibration techniques. First, we start with our personal protective equipment. As always, we want to make sure all PPE is worn throughout the entire installation. This would include things like eye protection, safety glasses, or goggles, N95 respirator, protective gloves. If working with metal studs, we want to use cut-resistant gloves, and earplugs. We also want to make sure that all safety measures on all of the equipment are in a proper working order before we start. Some of the equipment needed. We'll need a blowing wool machine, a stapler. Normally this is an automatic stapler, air compressor, staple hammer, utility knife, a scale, usually a digital fish scale works the best, a measuring tape, and a blowing nozzle if desired. So the blow machine is our delivery system. Bales of blowing wool are placed in the hopper and go through a series of paddles that break up the material and start processing it. Material then falls down into a rotating paddle wheel and is blown through the hose into the job where the applicator will install into the cavity. The remote allows the installer to control the blow machine from the interior of the job. Remotes come in both wired and wireless format and is an essential key for proper installation. Staplers are used to attach the fabric to the wooden studs. These come in a wide variety, but the most commonly used for this type of application are pneumatic variable rate staplers. These staplers allow the installer to hold the trigger down, move along the stud face continually applying staples. In using these type of staplers, it is important that we adjust the rate of stapling so that we are achieving approximately 1 staple per inch. The adjustments on these are usually a dial or level on the stapler that we can set to achieve the desired result. We also want to make sure that we're using at least a 1/4 inch stapler so that it properly fastens the netting to the wall. The compressor is used to operate the pneumatic staplers. We just want to make sure that the compressor we use can produce enough CFM to operate the total number of staplers that we will be using. So nozzles are very important to the application process. The nozzle attaches to the end of the hose and is placed behind the fabric when filling the cavity. The nozzle allows us to achieve a more even distribution of blowing wool and aids in getting behind wires and around obstacles. The nozzles come in a wide variety of shapes and sizes and are designed for different application processes. In purchasing a nozzle, you want to make sure to ask what type of application the specific nozzle is used for. Before we can start the application process, we need to know how much material we'll be needing. This is a very simple procedure. We want to take the square footage of the wall area. We want to divide that by the square footage per bag at the proper depth and density by using the chart that we have listed here. For example, if we have a 2,000 square foot area, that is a 2x4, we can figure out usage by looking at the top line of the chart. 3.5 inches deep at 1.5 pound density, we should get around 72 square feet per bag. If we divide the 2,000 by the 72, that will give us a little over 27 bags. The chart that is shown here can be found on jm.com, and it's also usually on the back of the blowing wool bags as well. So now that we know how much material we need, we move on to calibrating our blow machine. First, we locate the air bypass on your machine. Sometimes this is a lever as shown, or it could be a weighted system or a simple high pressure valve. Our objective is to achieve 1.5 to 2 psi. This is done by turning the machine on, activating the blower only, no material flow. We then will adjust the air bypass by either opening or closing the valve, or in the case of a weighted system, removing or adding weights from the slide valve until we are able to achieve the 1.5 to 2 psi that we need. If your machine has an air volume gauge like the one shown above, simply adjust until the gauge shows you that you're in the appropriate range. If your machine does not have an air volume gauge, you can purchase a dynamic pressure gauge to check your airflow. Very simple piece of equipment. This gauge simply slides into the end of a 3-inch hose, turn on the air only, no material, and the gauge will give you the reading, and you can adjust in small increments until you hit the appropriate range. After our airflow is set, we want to move on to calibrating material flow. To do this, we start by adjusting the gate. The gate controls the rate at which the material falls into the drum. Most machines, this will be between 10 and 15 inches, but it could vary depending on the design. If your machine has a transmission, make sure that is in second gear. And then to further dial in the material flow, hook up a hose, and we want to blow into a bag or a box. Blow into the bag for 15 seconds, and then weigh with a scale, preferably the digital fish scale. We want to be between 2.5 to 3 pounds of material in the bag. If our material flow is light, we will open the gate in small increments until we achieve the desired result. If the bag is heavy, we close the gate slowly until we hit the target. At this point, I would recommend marking where your gate and air bypass are set. This way, future setup processes will be much quicker and easier. So for the blow hose, we want to make sure to run a minimum of 150 feet of hose. Start with the largest section coming off the machine, stepping down to the 3-inch at the nozzle. For example, if we start with 4-inch coming off of the machine, the second section would step down to 3.5, and the third section would step down to a 3-inch diameter. If we're using more than 150 feet, we want to run the largest diameter of hose for the majority of the length and then step down the hose at the end. Make sure that each section that is reduced is done so with a reducer. Do not tape hoses directly to each other. The constant on and off of the machine will create material surges that can catch on hose edges and create clogs in the hose. We also want to make sure our hose is in a good operating order. Hoses like the one that was shown here are worn out. The small ridges that help tumble and process the glass are worn away. This will negatively affect your yield. Also, the sidewalls in the hose like this are also very thin. The back pressure from the cavity fill can cause the sections to blow out, wasting material and creating messes that you'll have to clean up later. So, fabric installation is one of the most important parts of the entire process. Poorly installed fabric will lead to a host of problems once we start to fill all of the cavities. So some of the tools that we're going to need for this fabric installation would be utility knife, hammer, staple hammer, compressor if running a pneumatic stapler, tape measure, and of course our netting. On this, make sure that we are selecting the proper size netting for the wall, whether that be 8, 9, or a 10-foot wall. So the first step in the fabric installation is the wall prep. We want to go through each wall and remove nails, seal any penetrations, ink or foam small cracks and runs that we can't fill, and then tape over boxes if necessary. So once the walls are prepped, we can start fastening the fabric. In order to do this, we start by cutting the netting to fit the wall. Once the netting is cut to fit, we want to staple the fabric along the top plate for the entire length of the wall that we are working on. Next, we pull the stud of the wall, pull the netting down tight and staple to the bottom plate. Then move on to stapling both bottom corners, making sure to pull each corner taut. Stick aside and begin stapling the fabric at 1-inch intervals along the vertical studs while keeping the netting taut across the entire cavity. After that, staple the fabric to the bottom plate after each stud. Then we go through and we're going to hammer in any protruding staples and use our utility knife to cut out fabric around windows and doors. Do not cut out electrical outlets at this point. If we cut out electrical outlets at this point, the material will tend to blow out around those outlets and create a larger mess. On garage and interior sound walls, we may need to be netted on both sides, so just keep that in mind. So here we have a quick visual kind of to help understand the stapling of the fabric on a wood frame wall. So one, we staple along the top plate of the wall. Two, we find we find the midpoint of the wall and staple that. Then find one corner, Then staple the other corner, making sure to keep these corners taut. After that, we staple down the face of each individual stud in 1-inch increments, allowing the fabric to be pulled tight. With steel stud application, the majority of the equipment needed is similar to the wood application, except in this case, we're going to use an adhesive to apply the mesh instead of a fastener. We also want to make sure that we are wearing cut-resistant gloves when doing this part. If you're using a VOC-based adhesive, make sure that the work area is properly ventilated. We want to apply adhesive to all stud faces, top and bottom plates, and allow the adhesive to become tacky. Once tacky, we want to attach the netting to the first stud, working up and down the stud face first, then across the top and bottom plate while keeping the netting taut, and then pull over to the next cavity and press the netting along the top and bottom plates again. We want to continue this process until the wall is complete. We want to make sure and check that the adhesive is fully dry before we start to fill the cavities. It's also a good idea to wear cut-resistant gloves doing this and to make sure that you work with at least 2 people. So for the fiberglass installation. The fiberglass installation, we want to start by cutting a 4-inch slit at the midpoint of the cavity. The wall is tall, or you have obstructions in the cavity, you may need to cut more slits to compensate. Next, insert the hose or nozzle into the cavity and push down to your approximately 18 to 20 inches from the bottom. Turn on the switch and move the hose back and forth evenly, distributing the material in the cavity. Slowly pull the hose back as you start to fill the material, start to push against the hose. When the fiber fills to the insertion hole, I'm going to invert the hose, push it up in the cavity until you're approximately 18 to 20 inches from the top. Again, use a back and forth motion to distribute the fiber evenly. Slowly back the hose down as you fill the material, start to push against the hose. Once you have reached the insertion hole, turn the switch off, move to the next cavity. So once the wall is complete, we want to lightly run a push broom or even a roller over the cavity. This will help flatten any of the cavities that might have slightly overfilled. Then we can go through and cut out any outlets, and we want to check around wires and obstructions to make sure that we do not have any voids or light areas. Density checks ensure that we are achieving the proper density in the cavity. This will help us maintain proper material usage and ensure that the material will not settle. We want to make sure that we test at least the first 3 to 4 cavities at the beginning of every job, and then approximately every 1,000 square feet afterwards. So the tools to do the density check that we'll need will be the measuring tape, straight edge if desired, utility knife, a cardboard box or a 2-gallon plastic or fabric bag, and then the digital fish scale. So what is our density? The density is the weight of the material per cubic foot. So it is important that we take these samples from wall areas without any wires or obstructions. It may be a good idea to mark these areas to sample before we fill the cavities. The target density that we want to achieve is 1.5 to 2 pounds per cubic foot. In order to do this, we need to know how to calculate a cubic foot in a cavity. So in order to find the cavity area, we need to remove a cubic foot of material. In order to do this, we need to remove a cubic foot of fiber from the cavity. And to do this, convert a cubic foot into inches, which is simply 12 by 12 by 12, and this will give us 1,728 square inches. Next, we multiply the width of the cavity by the depth. For this example, we are using a 2x4 by 16 cavity. So if we multiply the 14.5 width by the 3.5 depth, we end up with 50.75 square inches. Next, we divide the cubic number, the 1728, by the cavity number of 50.75. This will give us the cavity length of 34 inches, and this will give us a cubic foot of material when removed. Here we have a chart of the most common cavity sizes. If we look at the highlighted box, you can see that a 2x4 wall, 16 on center, we are removing a 34-inch area. But on a 24-inch on center cavity, we are only removing a 22-inch area. While you can use this chart for most instances, it's a good idea to learn the calculation in case a job falls outside of what is normally done. So cut an area, remove an area 34-inch section of netting and prepare your bag for weighing the fiber. Place a bag or box on the scale and tar it so that it is set to 0. Remove the material and place into a bag or a box and take your reading. So the receptacle weight is going to equals the density per cubic foot. For example, the weighed bag equals 1.5 pounds, and our installed material density is 1.5 pounds per cubic foot. If the cavity is light, we want to increase air pressure and material flow in small amounts until proper density is reached. If it is too heavy, reduce the settings in small increments until achieved. It is important that we try to get as close to the desired density as possible. If we are aiming for a 1.5 density and we installed the project at a 1.7, we're putting approximately 12% more material into the walls than we should. This can become quite expensive by the end of your project. Last, we replace the netting over the tested area, and then we reinstall the material. Quality control and routine inspection of the net and blow system during installation is crucial and should be performed throughout the project. Checking for quality issues as the job is being done allows for problems to be resolved and will save costly return trips later. We want to check anywhere that electrical wires are ran through walls. Material will tend to hang up on these wires, and at the bottom parts of the cavity may be loosely packed. Check around electrical boxes and wall penetrations. These areas tend to have voids around them and can be easily missed. Garage partitions and interior sound walls that are netted on both sides can be overfilled. We want to be cautious and make sure that we do not pillow or overfill the cavity and cause problems for the drywall crew later. Johns Manville has a wealth of technical resources. If you have questions or require assistance with any of Johns Manville's installation products, please contact any member of the TechConnect team. They're highly trained and ready to help. That will conclude what I have for net and blow.
Great, thank you so much, Jacob. In addition to the TechConnect team that you saw listed there, this is our TechConnect hotline. So if you don't have a specific person in mind that you'd like to call and you're just looking for some technical support, we do offer TechConnect for anybody who's a JM customer who's looking for additional resources. Maybe they're having some issues with blowing wool, spray foam, even architectural specifications. Our TechConnect group can actually support you on all of those fronts. So the phone number there is 800-654-3103. And if you call that, they can get you pointed in the right direction. In addition to TechConnect, we do have one more upcoming webinar in our TechConnect 5 Live series. And the next one is the SPF 10 Golden Rules. Our previous webinars, properly mothballing spray foam equipment, blowing wool machine and accessories checklist, and spray foam gun maintenance are all available on demand on our website. You can access them by going to the building installation page of the JM website, which is jm.com. And on the left side of that page, you will see a menu that has webinars in it. And if you click on that menu, that will allow you to go watch these webinars on demand. Also, for everybody who attended today, you will get an email with a link to each of those webinars. In addition to our 5 Live series, we do have a series of AIA certified webinars coming. So if you need any, these are available for continuing education credits. So anybody who attends will get a certificate of completion. We just had our first one last week, and that was on walls that work. Next week, on April 23rd, architectural acoustics. That'll be hosted with Jeffrey Job. And then next week on Thursday, we will have one on continuous insulation. So with that, we're going to take it to some questions. First and foremost for you, Jacob, is why do I need to check the density?
So densities are going to determine your material usage throughout the job. Like we mentioned before, slightly going over on density throughout the job can actually lead to quite a bit of material loss and more money loss.
All right. What should I do if I overfill the cavity? Do I have to tear the excess out?
No, you do not. Most times you can press the material down into place. We just want to be careful that we don't pillow too much because this will kind of affect the drywall guys later.
This question is, what happens if I underfill the cavity?
If you underfill a cavity, the cavities can tend to settle and be less dense and cause gaps, which is the reason why we do a net and blow anyway, is to prevent those gaps. So like I said, always check your first 3 to 4 cavities and make sure, and then every 1,000 square foot after that, you should be fine.
All right. How long does it take to fill a standard 2x4 9-foot cavity?
So that depends heavily on your equipment. I can't give you an exact time. Some machines are bigger than others, some are smaller, so it's hard to give an exact time on when we'd be able to, how long it would take to do that.
All right. The next question is, do I need to air seal if I use net and blow?
Yes. Although the fiber does resist airflow, it does not air seal.
All right. The next question is, does JM provide the netting?
No, JM does not provide netting.
All right. Next is, how did you fix the fabric to metal studs?
So we're going to use some kind of an adhesive. The majority of what I see is 3M adhesive that is used to spray on. That 3M adhesive sprayed onto all the faces. You allow it to become tacky, and then you want to attach the fabric in one direction along the wall to each stud face while a secondary person is keeping that fabric taut.
All right. The next question is, can I just take 1 square foot of material and check it against the chart weight for a density check?
No, because 1 square foot of material is not a big enough area to figure the standard of the cavity. You could be on in 1 square foot, but still off in another square foot. So we need a larger measurement in order to get a proper reading.
All right. The next is, can I set my machine to stall when it's reached the proper density?
No, that's what the remote cord is for. We don't want to stall out the machine.
All right. And the final question I have thus far, oh, I might have 2 more coming in. So sorry. The first one is, where can I purchase the netting in Canada?
That I do not know. You would have to get a hold of your local Canadian rep, and they would be able to tell you exactly where to get it. Usually from most places that you acquire from distribution can steer you in the right direction.
All right, and now our final question is, wouldn't the JM Spider product be much easier for doing metal studs than trying to attach netting? And if you could go ahead and explain what the JM Spider product is as well, that would be great.
So the JM Spider product is its final application is somewhat similar to the net and blow. It's sprayed into place, but with no netting. And it's sprayed into place and it gets similar densities, but there's no netting or glue or anything like that that's required. It would be easier, but it may not be applicable in all cases. If you have extra wide cavities, sometimes it's going to be easier to do the net and blow than trying to get the spider to stay in.
Okay, and we did have one more question come through, and that is, are there any concerns about drywall if I'm doing a retrofit install?
Yes, retrofit is a whole different ballgame. That's something that we didn't cover in this, but if you have those questions or you need that help, the tech team is more than versed in it, and we can help you with anything you need. All
right, excellent. Well, that wraps up all of our questions for today. So thank you very much, everybody, for attending. We hope you'll join us next week, Tuesday at the exact same time for our final webinar, the 10 Golden Rules of Spray Foam. And we hope you found this helpful and are able to access all these webinars on demand in the email that we send out here in the next couple days. So thank you, everybody, for joining us.